On the evening of August 21, 1986, Lake Nyos appeared peaceful. The deep blue water filled an ancient volcanic crater in the highlands of northwestern Cameroon. Families lived in farming villages throughout the valleys below. Nothing suggested that the lake was storing an invisible threat. Then, without a conventional volcanic eruption, an enormous quantity of gas suddenly escaped from the water. There was no river of lava and no towering cloud of ash. The gas was carbon dioxide, colorless, almost impossible to detect without equipment, and heavier than ordinary air. It poured over the crater's edge and flowed downhill through the surrounding valleys. Entire communities were caught before most residents understood that anything was wrong. By the following morning, the countryside had become unnaturally quiet. At least 1,700 people had died, along with thousands of livestock. Some survivors were found in areas where the gas had become thinner or where higher ground offered protection. Lake Nyos had produced one of the strangest natural disasters ever investigated. Scientists arrived from Cameroon and several other countries. At first, they considered whether the lake's volcano had suddenly erupted, but surveys found no convincing evidence of a recent explosion beneath the lake. The lake floor appeared largely undisturbed, and its deepest water did not show the strong heating expected from a new eruption. The answer was hidden in the unusual structure of the lake. Lake Nyos sits within a volcanic region. Carbon dioxide originating beneath the surface enters the bottom of the lake through underground springs. Because the lake is extremely deep, the pressure at the bottom allows enormous amounts of gas to dissolve into the water. The process can be compared to carbon dioxide remaining dissolved inside a sealed bottle of soda. While the bottle stays closed and pressurized, the gas remains mostly inside the liquid, but when the pressure is reduced, bubbles rapidly form and rise. At Lake Nyos, the water was arranged in stable layers. Cooler upper water acted like a lid, while deeper water gradually collected more dissolved carbon dioxide. For years, the lake silently stored the gas without revealing the danger on its surface. Something disturbed that balance on August 21. Scientists have proposed several possible triggers, including a rockfall, a landslide, heavy rain, or the natural movement of water inside the lake. The precise trigger remains uncertain. Once some deep water began rising, the pressure around it decreased. Dissolved carbon dioxide formed bubbles. Those bubbles made the water more buoyant, causing it to rise faster and pull more gas-rich water upward. A self-sustaining chain reaction began. The lake released a massive volume of carbon dioxide in what scientists now call a limnic eruption. Deep water surged toward the surface, and the expanding gas created violent movement across the lake. Iron-rich water brought upward from the depths also changed the lake's appearance. The escaping carbon dioxide formed a ground-hugging cloud. Because it was denser than the surrounding air, it followed the landscape downward rather than quickly rising into the atmosphere. As the cloud entered low valleys, it displaced breathable air. Its invisibility made the danger especially difficult to recognize. People could not see flames, smoke, or ash warning them to escape. Communities closest to the lake suffered the greatest losses. Villages were evacuated, and many survivors were eventually relocated because scientists feared that carbon dioxide would continue accumulating beneath the water. Investigators also examined Lake Monun, another Cameroonian crater lake, where a smaller gas disaster had occurred in 1984. The two events demonstrated that deep volcanic lakes could store dangerous concentrations of dissolved gas. Measurements taken after the Lake Nyos disaster showed that carbon dioxide was continuing to enter its deepest layers. Without intervention, the lake could gradually recharge and become dangerous again. Scientists and engineers developed a controlled degassing system. A pipe was lowered into the gas-rich water near the bottom. When deep water was brought upward, falling pressure caused carbon dioxide bubbles to form. The bubbles lifted more water through the pipe, creating a self-powered fountain above the lake. Controlled degassing began in 2001 and reduced the amount of carbon dioxide stored below. Additional engineering and monitoring strengthened the effort to prevent another uncontrolled release. Lake Nyos remains carefully observed. It is one of only a few known lakes capable of holding such high concentrations of dissolved gas in their deepest waters. The tragedy transformed scientific understanding of crater lakes. Researchers now study water layers, gas pressure, and geological activity to identify similar hazards before they become disasters. Lake Nyos looked peaceful because its danger produced no visible smoke and no constant eruption. The threat accumulated silently beneath calm water. What happened in Cameroon revealed a frightening truth about nature. Sometimes the most dangerous cloud is the one nobody can see.